Welcome back. In this video we're looking at algebra expressions. And we're not talking about like facial expressions that try to describe algebra. We're talking about how we write an expression in algebra, how we physically write it. So the learning intention for today is understanding and explaining what is meant by an algebraic expression and converting worded statements into algebraic expressions because maths is lazy. We don't want to write out words when we can write it in a couple of letters. So you're welcome. So an algebraic expression is a form which contains numbers, variables, and operation signs. So numbers we're cool with, variables are our letters, the A, B, C, etc. And the operational signs are things like times, divide, multiply, add, subtract, etc. For example, we've got things like 2x plus 3, 5a minus 4b, t squared minus 6, all divided by r. These are all examples of algebraic expressions because they contain those things. It's important to be able to today, Junior. It's important to be able to convert worded phrases into algebraic expressions and vice versa. Let's look at some practice. So firstly, we're saying in words, write the meaning of these sentences. Then we're saying convert these statements into algebraic expressions. And then in 3, 4, and 5, it just gets a little bit more complex. We've got a couple of different things and we're trying to figure out how do we write that as an algebraic expression. So one hint with those is that the unknown is always our variable. It's the letter that we choose. So whether you choose X or A doesn't really matter too much. If you choose a letter and it's different to what the answer has, that's okay as long as the expression is the same. So in some of these, I think they've already told you that they want to use X. But you could just say, I'm going to call it A because A is my unknown variable, and then I'll think about what things affect A when I'm writing my expression. So answers for this are going to be up in 5 seconds. Pause the video and have a go at these questions. Answers above. So this picture of this handsome gentleman here is Isaac Newton. He is a very famous man in the physics world, because he discovered a lot of things. People say he discovered gravity. He was pivotal to explaining gravity. He did a lot of work explaining planets and the motion of planets and things like that. And the other thing that relates to what we're talking about is he came up with these 3 equations of motion, and they were called Newton's equations of motion. So these will actually make a lot more sense later on when we talk about motion in science. But it's a great example of seeing algebra in the real world that we use all the time. And I teach this to my year 11 physics class all the time. My year 12s use this a lot. It's very, very handy. So these 3 equations of motion are talking about velocity, which is v. This is our initial velocity. So the 0 in physics language means initial. And if I don't put a 0 on it, it means like the final or the current. So what it's saying is, the velocity of some object, let's just say speed, the speed of an object is equal to the speed that it was traveling plus how much it accelerated by times how long it accelerated for, which kind of makes sense. If you're moving at some random speed, I want to know, okay, what was your initial speed? How fast were you moving? And then did you speed up? And if so, how long did you speed up for? And then I'll add that to your initial speed. I get your total speed. So that's one of the equations of motion. The next one here is talking about distance, s, makes sense later. Distance is equal to, so this is distance that you've traveled. It equals to the velocity, so how fast you were traveling, times how long you were traveling for, plus this slightly more complex equation, which is just half of the acceleration, so if you sped up or slowed down, multiplied by the time that you did that for, squared. So this bit's a little bit less intuitive, but this bit definitely makes sense. How far you travel equals how fast you're moving times how long you're moving for. And his last equation was that the speed that you're traveling squared is equal to your initial speed squared plus 2 times the amount you accelerated by multiplied by how fast you traveled in that distance. So it's a pretty impressive set of equations that can basically find almost everything we want to know about the motion of an object. So Isaac Newton gets the Physics Thug Award for this lesson. So success criteria check time. Ask yourself, can I understand and explain what is meant by an algebraic expression? And can I convert these worded statements into algebraic expressions that we saw before? and we want to do that accurately. So if you made 0 or maybe 1, but now you've looked back at it, you know where you went wrong, mistakes in those previous questions, you can tick those boxes and we can say, we've accomplished this task. Let's move on to the next amazing maths lesson.
Xantiver's Hartford.